Polyatomic ionic compounds. So these are ionic compounds that contain polyatomic ions. Polyatomic ions contain at least two different atoms. You're going to learn the names of the most common ones. Ammonium, NH4 1 plus, is the only positive one we will use, and the ammonium ion will take place of a metal in the ionic compound. The most common ion will end in ATE. Phosphate, PO4 3 minus. Nitrate is NO3 1 minus. The number of oxygens depends on the element it's bonded to, like P versus N, phosphorus versus nitrogen. It's not a set number for every element. So you've got to know which formula is the 8 for each of the elements. One less oxygen in their formula and they become ite. PO3 3 negative is phosphite. NO2 1 negative is nitrite. The charges stay the same. So you can change the number of oxygens, but you don't change the charge. Some of our polyatomic ions also end in IDE. Halogens have a special set of names because they can have 4 different oxyanions. Oxyanions is a negative ion where there's an element bonded to oxygen. So the examples phosphate, nitrate, phosphite, nitrite, these are all oxyanions. They're negatively charged ions, and to make them polyatomic, they have oxygen in their compounds. So in this table, I've shown you the formulas for all of the halogens, the possibilities for the halogens for oxyanions. Here, you can see we've got the halogen represented by an X. So you just substitute in the halogen and you'll get your formula. So the most common formula for a halogen oxyanion is O3 1 negative, and this ending becomes ATE. So if it's chlorate, if your halogen is chlorine, it becomes chlorate. 1 less becomes chlorite. But sometimes you can have 4 oxygens, like in the top example. And then you have to put a prefix per in front of chlorate. So it becomes perchlorate. If it was bromine, BrO4 1 negative, it would be perbromate. And then 2 less than the most common ion is hypoite. So hypochlorite, hypobromite. So all of them will have XO3 1 negative for the halogens as the most common ion. So the naming goes off of this. This is the 8, 1 more than this, and it's perate. 1 less than this, and it's ite. 2 less oxygens, and it's hypoite. So this is specific for the halogens. So as I mentioned before, some polyatomic ions end in IDE. Hydroxide is a very frequently used one, and cyanide is another example. So on the back of your periodic table that I gave you, there is a table of polyatomic ions, and polyatomic ion tables are in most textbooks, and you can use these as references until you start getting the handle. Do lots of examples so that you don't need to rely on the table anymore. By doing something repetitively, you learn things. So it's just like learning the times table. Some rote memorization is useful. But you're going to, because you use them so many, you will be able to identify them. All right. CaNO3, 2. What you want to do when you see a formula is to identify right off the bat what is the polyatomic ion. So here we have NO3, and we know the first element is calcium, and NO3 is the most common ion for nitrogen, so it's nitrate, ends in nitrate. For the next example, the polyatomic ion is the NO2. That has one less oxygen than nitrate, so that is sodium. Nitrite. So when you write names, you identify the cation and then the anion. If you have Roman numerals, then you have to use the reverse crisscross or the zero sum to identify the charge. But you're going to need the table to start with if you're unfamiliar with your polyatomic ions. The next example, the polyatomic ion is actually the one out front. So this NH4 is ammonium, and this is followed up with chlorine, so it's chloride. The same rules apply that applied before, and that is the ending on the second element changes to IDE. So the next compound has two polyatomic ions in it. So this is ammonium. And then if you look that up, that is carbonate. Carbonate. Wow, I don't know what happened there. Apparently I can't spell. There, my brain was obviously not working synchronously with my hand. Okay, so ammonium carbonate. Okay, the next one we've got Cu, so that's copper, and SO4, that's sulfate. However, copper can be either +1 or +2. So you can do the reverse crisscross. Cu, SO4. Now, SO4, that 4 is with the oxygen in sulfate. So you don't treat that as a subscript. That just identifies the actual formula on that negative ion. So really, there's a 1 over here and a 1 over here. So if you do reverse crisscross, it's like they both have the charge of 1, but we know that sulfate, SO4, has a charge of 2 minus. So we have to multiply both by 2. So that means that's 2 plus, and that's 2 minus. If you were going to do the crisscross rule, if you were going to do the zero sum rule, you would do the charge on sulfate is -2. Therefore, the positive charge has to be +2 for these two numbers to add up to be 0. So I know that either way, this is copper to sulfate. So you have to put in the Roman numerals. All right, KCN. Here, the polyatomic ion, you know the polyatomic ion is the negative ion. And this one, oops, let's get rid of this. There. The polyatomic ion is the second one because the first one is not NH4. So it's sort of process of elimination. So this is potassium for the K. And then CN, 1 negative, is the cyanide ion. So this is potassium cyanide. Okay, we'll do a couple more examples. CaSO3. Well, SO3 is not sulfate, it is sulfite. It has one less oxygen than sulfate. So this is sulfite. And you can do sulfur, sulfite with a pH instead of an F if you choose. Either one is acceptable. MgOH2. The OH is hydroxide. So this is magnesium hydroxide. You must use your polyatomic ions. This is not magnesium, oxygen, hydrogen, ide. So magnesium hydroxide. You look for the grouping of atoms and find them in the table until you get proficient. Now this second last example, we have sodium. So we can identify that. And then we have HCO3. So this is hydrogen carbonate. Sometimes it's called bicarbonate, sodium bicarbonate, but that's a more common name. The IUPAC rules are sodium hydrogen carbonate. The next one's unusual too. There's our metal. So it's silver. And then this group of atoms is also a polyatomic ion, and they have a specific name, and it is acetate. We will be using this frequently. So silver acetate, and that's how you name polyatomic ionic compounds or ionic compounds containing polyatomic ions. You must look up the polyatomic ions, have some sort of reference chart in order to complete this if this is brand new to you.